our third and final program for this lesson. It's another one that involves some conditional statements. The user is going to enter any positive integer, and the calculator is going to determine if that number is even or odd. So kind of like the last program, if a number is just written on your paper, who knows, maybe 14, you could tell within an instant whether or not that's an even number or an odd number. What do you usually do? For even numbers, yeah, it means that the number is divisible by 2, but you don't do that. You don't actually divide this thing by 2. No, you just look at the last digit and you look to see, does it end with a 0, a 2, a 4, a 6, or an 8? And if that's the case, it's even. If it's not, then it's odd, right? That's usually what you do. But that's not how we're going to be able to put this into the calculator. We say, oh yeah, calculator, look at the last digit. Yeah, and then tell if it's a 0 or a 2 or a 4 or a 6 or an 8. Okay, that makes it even. No, we're not going to do that. So we have to base it on the definition of even and odd in the same kind of way that we did for positive versus negatives. So think back to those first proofs that we did about even and odd numbers. What did it mean for a number to be even? Well, we said that it's divisible by 2, and then algebraically that means that it could be written like this. Do you remember this? 2 times some sort of integer, 2 times n, where n is an integer, right? It means essentially that whenever you divide your number by 2, the remainder is 0. And this part right here that's in the box, this is exactly what we're going to do in order to code this. So let me show you on your calculator a cool little feature, a little function that's built into the calculator. And it has to do with the remainder. So you remember that whenever you first learn to divide a number, you didn't deal with decimals and stuff. It didn't go in evenly. Instead, you had this big old R, like remainder of 3 or something like that. So let's just say, for example, I take 19 and I divide this thing by 2 and I get 9.5. So 9.5, it doesn't go in evenly, doesn't get a whole number as an answer. So I know that that's, it's got to be an odd number. But what's the remainder here? If I have this 0.5 that's tagged to the end of this, what was the remainder? So if you divide something by 2, that's what I want you to think about. What are the possible remainders? Well, if it goes in evenly, the remainder should be 0. But sometimes there could be 1 left over. Could there be 2 left over? Well, if there was 2 left over, then 2 could go in it one more time. Okay, so our calculator has this built-in remainder function. Let me show you where that's at. It's under the math menu. You can scroll down here in math. There's a whole bunch of stuff that involves calculus and stuff. So maybe one day. Go over to num and just keep scrolling down here. I think that there might be something. Oh, there we go. So before I hit enter on this, you see it says remainder. There's a little parentheses. So usually that means that you got to type something in there. And hit the plus sign. I guess pull up the help menu, and it tells us what it is that we're supposed to type in there. So it says dividend, comma, divisor. Dividend is the number that's inside the division house. That's what you're dividing into. Divisor is the number that's outside of the house. It's what you're dividing by. So let's see what happens here. So I'm going to hit this paste button, which is this F4. It puts it on the home screen. I'm supposed to separate these things with a comma. So I'm going to do the same problem that I did up here. I'm going to do 19 and 2. So 19, follow it with a comma, which is right above the 7 key here, and then a 2. Hit enter. Don't hit enter, close the parentheses. Okay, so it's going to divide 19 by 2, but it's not going to tell you 9.5. It's going to tell you what's left over after you divide by 2. It doesn't tell you it goes in 9 times with like 0.5. No, so watch. It says there's 1 left over. Let me try another one. So I'm just hit second enter. This time I'm going to do 20. Wow. Okay, so just type in 20. So think about this. If you divide 20 by 2, what's going to be left over? What should be the answer to this problem? 0. It goes in, and there's nothing left over, and that's the definition of an even number. And this is what it is that we're going to use in order to determine if our number is an even number. And we won't have to do the same kind of thing for odd, because if it's not an even integer, it must be an odd integer, right? Okay, so that's it. These are the only 2 possibilities. whenever we're dividing by 2. Let me just extend this just a little bit here. And let's say that I'm going to divide a number by 3 instead. So if I divide this by 3, so think about this. 3 goes into 20 how many times? Okay, I don't really care about that. I care about what's left over. Hit enter. Look, there's 2 left over. How big can that remainder get when you're dividing by 3? Well, if it goes in evenly, it could be a 0. That means it's divisible by 3. It's a multiple of 3. Sometimes there could be 1 left over. There could be 2 left over. But could there be 3 left over? Well, if there was 3 left over, then that means that 3 goes in it one more time. So notice that whenever you're talking about the remainder, it's always, the maximum number is always 1 less than the number that you're dividing by, right? So for our 2, the biggest remainder could be just 1. And there's only 2 possibilities, either a 0 or it's a 1. So let's go back and do some brainstorming work in order to figure out how to code this before we put it into the calculator. All right, so let's assume that we're going to get the number 0, not the number 0, the number x. We'll input the number x, and we'll do our whole thing with x. So input x. Okay, let's build our conditional statements. So for even, that means that whenever I divide this thing by 2, the remainder should be 0. So I'll just write in English what my if-then statements are going to look like. So if remainder, and I'll put x comma 2 here. So it's going to take the number that they input, it's going to divide that thing by 2, it's going to spit out a number. And if we're dividing by 2, the only possibilities are 0 or 1. If this remainder is equal to 0, then x is even. If the number's not even, it has to be an odd number. So let's just say, for example, our x is equal to 4. Okay, so if I put a 4 in here, it takes this 4, divides it by 2. It goes in there 2 times with nothing left over. So this condition is satisfied and then concludes that 4 is even. Let's now try x is equal to 5. So if I plug 5 in here, 5 divided by 2, it goes in there 2 times, but it has 1 left over. It doesn't satisfy this, so this part is ignored and it doesn't do anything. So I have to code for what happens if this condition is not satisfied, and I separate that with the word else. Else x is odd. So now let's again test it with this number 5. So if we plug that 5 in here, we said the remainder is 1. This part is ignored, and it goes to the else statement, and it says that 5 is odd, which is a true statement. So that's it. This is our conditional statements that we need to build into the calculator. And just keep in mind, we need to ask them for a positive integer here, right? Because that's what the condition of the problem was. All right, so let's start coding this. Pull up the camera in the calculator so you can see it. Okay, we'll have to start a new program. Do a new one. Name the thing. It's alpha locked already. I don't know, maybe I'll just call it E, V, E. If I can only find the N. Even. I'll call it even. Whatever. All right, now I'm going to start off with the input mode. I need to tell the user what it is that we're looking for. We're looking for a positive integer. We'll do that with a display. So hit the program button. Input, output, it's number 3. There's that space after the word display indicating I'm supposed to type here. If I want text, I need to put it in quotation marks. So I'm going to alpha lock that. Quotation right above the plus sign. Enter, positive integer. So I'll just abbreviate just about all of that. E. There it is. All right, got enter. Riveting. Okay, now hit the space. Enter. And I'll abbreviate positive with just POS, another space, enter positive, and then integer, I'll just do INT. That should do it. Enter positive integer. Hit enter, so it'll type that on the screen, and now I need to get the number from them, and we'll do that with another input. So program, IO, and then just choose number 1, and we're going to store that as X just because it's super convenient. It's just right there. All right. Input phase it's done. I got the number from them, and now I need to test this number. So we'll start our conditional. So we're going to start with that even. So we'll go to program and choose our if, number 1 there. There's that space that's after the word if. That means I type my condition here. Oh, but here, I'm going to show you something that's a little bit more elegant than just putting the remainder thing inside here, because chances are in some programs, you have to use that thing repeatedly, and you don't want to have to keep typing it over and over again. So what I can do is I can just calculate the remainder and then store that as something, maybe R, that makes sense for remainder. And then all I have to do in the condition is just type in the letter R. So that's actually a more elegant way to do this. So let me clear this part out. And let's just calculate the remainder and store it. So math, go over to num. Actually, if you scroll up instead of down, you'll see it here at number 0. And then inside here, what are the 2 things that we're going to put? The number we're going to divide into is the x that they gave us, separate it with a comma, and we're going to divide it by the number 2. Close those parentheses, and we're going to store that one as some variable like R. We store it with the store button right above on, and it puts a little arrow here, and then hit alpha R. There we go. And now we just do our testing on R instead of having to type all of this stuff over again. And that's useful if I have to do a calculation with the remainder thing more than once. This time I really don't, but it's just a nice, elegant way to type this thing up. All right, so program, now let's do our conditions. If I'm going to test R, I'm going to see, is R equal to 0? Is the remainder 0? So alpha R. And equal sign, where the heck is that? It is underneath the test menu, just like the inequality sign. So second math, and it's the first one there. Is R equal to 0? Is your remainder of 0? Remember, you don't put a comma here, so just hit enter. And the word then always follows if, which is back under the control menu, number 2. Notice where the cursor is. It's right after the word then. There's no space, indicating you're just supposed to hit return. It gets its own line. And then we're going to say, hey, that remainder is 0. That means it's an even number. So just display even. Program, IO, disp, and then in quotation marks, even. All right, that didn't take exactly forever. Close those quotation marks. Boom, hit enter. All right, but what if the remainder is not 0? There's only 2 possibilities. It's 0 or it's 1, so I need to code for that possibility that it's 1, and I do that with an else. Program. Number 3, it gets its own line. Display that it's an odd number. So program IO. Number 3, alpha lock it again, quotation marks, and then type to the best of your ability, odd. There we go. That should do it. And now we need to test it out. We need to see, does this actually work? So inside here in the conditions, we did both the calculation phase and the display for the user phase. And let's quit out of this. Second quit so we can test this out. Program. I'm going to execute. It was even, I believe. Hit enter. Enter, pause, integer. I think that means positive integer. All right, so I'll put in the number 8, hit enter. It tells me it's an even number. Oh my God, it's like magic or something. Hit enter again. Let's try another one. Let's try something like 89. Hit enter. Oh, look at that. It's an odd number. It did it correctly. All right, let's now one of the things that you want to try to do with your program is see if you took everything into consideration. Is it possible that you can break the program in some kind of way because you didn't take something into account? And that's usually what happens in beta testing before it goes out to the market, so that you work out all the kinks. So let's run it again and see what happens if we plug in, I don't know, let's see if we plug in 0. Is 0 an even number? Yeah, 0 is an even number. As a matter of fact, whenever you look for an even number and you look at that last digit, 0 being one of those digits that you look for, that's an even number for sure. Fits the definition. Okay, but how about this? How about Let's see what happens when we put in 2.5. Whoops, I guess I have to call the program back up here again. Enter, and then put in 2.5. Hit enter. Ooh, we broke it. It says error, and it's a domain. So a domain error, that means that whatever it is that you're supposed to stick into a function. Let's hit go to, and let's see where it says that in the program. Oh, it's right here. It's in the remainder function. So apparently this x that's in here, it can't be 2.5. So let's quit back to the home screen, and I'm just going to go to the remainder and see what happens here whenever I play around with it. Right there. There we go. And it's this 2.5 comma 2 here. This is what broke it. And the reason why is because you can't put a decimal number inside of the remainder function. It's outside of its domain. The required things that get to be input in for that function. These have to be integers. So yeah, we told the user to only enter in a positive number, but nobody ever pays attention to that. Sometimes someone's going to try to put in something that doesn't work, either on accident or on purpose, and we want to make sure that our program doesn't break. So what I would like for you to try to think about is, how could we idiot proof the program? Could we edit the code in some kind of way that it doesn't stop the program, it just tells the user that they input something wrong, like user error or input error, something like that, instead of having that error that we had before. But there's one other thing that sometimes breaks it too. So let me try this again. I'll just scroll back up here. And this time, what if I put in -6? Is -6 an even number or an odd number? Since it's a 6, it's an even number, and even numbers can be either positive or negative. That's okay. So this should say even, but it says a domain error again. And once again, the reason why is because of that remainder thing only wants positive integers. So that's something else that I want you to think about. So if you go back to your code, you go to edit, and go in here to even. So before this remainder function is calculated, see if you can weed out all of those idiots who try to put something in that's either a negative number or is like some sort of decimal number. So it's going to take some extra coding. You may have to enter in some extra lines in here. The way that you do that is with inserts. So second delete inserts, you may have to add some extra stuff in here, some extra conditions, so we can idiot proof this program. And I'll give you a few hints. The things that you're going to need are under the math menu again, specifically under the num. So ABS, do you know what that is? Absolute value. And then there's some other stuff here that you might investigate, because there's some stuff here that you might use in your program to try to idiot proof it and take care of those cases where somebody puts in a number that's not allowed into the remainder function. All right. Other than that, that should do it.